That wasn't him? Okay, well, whatever, we're going. If the electric field, well, we're doing it anyway, at point P is that, determine the value of charge Q2. Okay, here's P. Right there. And there's 2 meters. There is Q1. And here, same distance, 2 meters. There is Q2. So that's not really to proportion, is it? Feeling a little OC this morning. So it's a little different than it's been worded before. And I recall some of you getting a wee bit confused in kinematics when you weren't trying to find the resultant, you were given the resultant. And that's what's going on here. Let me move that. You can't see it, but I can. That is the electric field at point P due to both of those two charges. So at point P, this is just a fictitious, this isn't a point charge. This is just a fictitious point where we want to know the electric field. Well, the electric field at P is due to these 2 points. It's always the direction a positive charge would go. So what does P feel from Q1? What direction would he want to go? He would want to get repelled. Okay? Due to Q1, it's wanting to go that way. Make sense? What does P feel due to Q2? That's a negative. He wants to get attracted to Q2. So I got this. It's supposed to be horizontal. I've got that. So the net for point P is going to be that and that. This is the resultant due to those 2 forces. That is what we're telling you this is. Is that English? Not really. That's the resultant. Okay, that's the net electric field at P. So that is 16,225. I can figure out this one because I have a value there. So P due to Q1, the electric field, let's call that E1. Let's call that E2. So E1 is KQ over R squared, and K doesn't change, that's a constant. Q is 4 microcoulombs. Doesn't like to write near the edge. And the radius between them is 2. Don't forget to square it. Hate to see you lose easy marks. Okay, so E1, the electric field at P due to Q1 is 9,000. What's the units? Newton coulombs. Let's put it there too. Okay, and we already know that's going to be left. Call it a force if you want, but there's no forces. This is electric field, so just don't get confused. Okay? So I got this, I got this. Can we find this? Yeah. E2, which I don't know, is going to be that squared. Beck, what are you doing? Going for lunch? Minus that squared. Take the square root of that. And E2, okay, is 13,500. Newton coulombs. Am I done? Did I answer the question? It doesn't say what is the electric field at P due to Q2, it says what is the value of the charge Q2? I know E2 is K Q2 over the distance between them squared at point P. I found E. What I want to know is what is Q2? So you can manipulate the formula first, or you can chuck in the numbers that you know and then figure it out for Q2. What do you want me to do? Chuck in the numbers. Okay, I know that. K is a constant. Q2 is what I'm trying to find. The distance between them is 2 squared, which is 4. So Q2 is 4 times that divided by that. Which is, I'll do it. Because what does that say? Yeah, 6 times 10 to the minus 6. Or,
6.
okay, because that's what the answer is going to look like if this is multiple choice, right? Six microcoulomb. Okay? And again, to some of you people who are highly resistant, this is a lot nicer to put in your calculator than bracket 9 times 10 to the minus 9 bracket, okay? Especially when you square stuff. So use it. Second function, E button, exponent. That's enough to finish the rest of the sheet, people.